Hey there. In the last video, we went through how to find to rewrite a function that's in exponential form like this into logarithmic form like this. And if you do not know how to do that, you need to go back and make sure that you watch that video first before you go into this video. And you also are going to need to know, and this is in the last video as well, that a common logarithm has base 10. And instead of writing it like this, we write it like this without a base. And if there isn't a base written there, then you know that it is base 10. If it says log with no base. There's another form that we're going to learn about later with base e, and it'll look a little bit different. But if you see log without a base, it is base 10. The main purpose for this video is to look at how to evaluate a logarithm without a calculator. And if you're asked to do it without a calculator, you're either going to have to estimate what the answer is, but what I'm going to do is give you values that are going to be exact. And so you're going to want to rewrite these logarithms into exponential form to see what power you'd have to raise something to. So we're evaluating logarithms, so we're going to be finding the exponent. A logarithm is equal to the exponent. So looking at this first one here, I'll call that number 1. What is the base? Well, there's no base written here, so we know the base is 10. So we're trying to figure out 10 to some power, and instead of writing a question mark in math, we usually use a variable because we don't know what it is. 10 to the x, it's an unknown, equals 10,000. What would you have to raise 10 to get 10,000? Well, 10 to the first is 10. 10 to the second is 100. 10 to the third, notice that whatever I'm raising it to, there's that many zeros. So 10 to the fourth would be 10,000. So this exponent here would be 4. So that's what I'm finding. When I'm finding the log of base 10 of 10,000, I'm trying to figure out 10 to what power equals 10,000, and it would be 4 because 10 to the fourth is 10,000. All right, so the next one is a little bit trickier. You're looking for 3 to some power equals 1 over 27. A couple different ways to do that. You can look at, well, let's rewrite it first, not 10. Space is 3. So rewriting this into, we don't know what it is, so I'm trying to figure out what x is. So I'm going to write 3 to the x equals 1 over 27. Well, what you're going to want to do here is, if we rewrite 27, over here the base is 3. And if I'm asking you to do this without a calculator, then you should be able to write the other term, the other side of the equation in terms of base 3. Remember that 27 can be written as 3 to the third power. Check that. 3 times 3 is 9, times 3 again is 27. So those two things are the same. And then this base is in the numerator. I could put that over 1. This base is in the denominator, so really the base is 1/3. I want to make it so the base is 3, so I can bring this to the numerator if I make this exponent a negative instead of a positive. So anytime you bring it across a fraction bar, you can put that over 1. You don't need it over 1, but you could put it over 1. But anytime you bring a term from the numerator to the denominator or the denominator to the numerator, the exponent changes sign. So 3 to the x is the same as, I would raise this, 1 over 27 is the same thing as 3 to the negative third power. So 3 to the what equals 3 to the negative third. Well, these exponents would have to match, so this would be negative 3. So to check that, 3 to the negative third power, does it equal 1 over 27? Well, to evaluate something with a negative exponent, we put it in the denominator, and then it becomes positive, and then you have 1 over 3 to the third, which is 127. So that works. Try to do the next one. Call this number 3. Try to figure out what the value would be there. You can pause the video and come back. I'm going to rewrite this though. 3 to the x was equal to 3 to the negative third. So the third one here, 2 to the what power, because that's the unknown, equals 32. And so you're going to have to, if you don't know it off the top of your head, just think 2 to the first is 2, 2 to the second is, I'll write it out, 2 to the first is 2, that's not correct, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. So 2 to the x, I can rewrite 32 in base 2 by putting it 2 to the fifth, and therefore if I take and raise this to the fifth power, I'll get 2 to the fifth, or 32. So this is equal to 5 because we're looking for 2 to what power equals 32, and that answer is 5. All right, so here's a couple more. We have log base 2 equals, or of 1/16 equals what? If you want to try to do these on your own and then come back and look at the answers, you should do that if you feel comfortable. Otherwise, I'm going to go through them here. You have 2 to the what equals 1/16. So we want to get the 16 into base 2. 2 to the x equals 16 is the same thing as 2 to the fourth. You're going to want to start like recognizing this. We just did this. So 2 to the fourth is 16. So I know that 16 can be written in base 2 by making it 2 to the fourth. And then how do you make that, instead of being in the denominator, come up to the numerator, make it to the negative fourth power. So 2 to the negative fourth power, if I evaluate that, I'm going to make it 1/2 to the fourth, which is 1/16. All right, so then 3 to the what equals 27. You should try that. 3 to the x equals 27. Well, it'd be 3 to the third, because 3 times 3 is 9, times 3 again is 27. Eventually you're going to start like having these down and memorized. Log of 10 means the base is 10 because it's nothing, there isn't one there. So 10 to the what equals 10? It'd be 10 to the first. So your answer, when you're evaluating a logarithm, you're finding an exponent. You'll hear me say that a few times. Next one, log of 0.01 has base 10 again. So 10 to what power equals 0.01? Well, that is a little bit tricky, but if you, there's a couple different ways you can think of this. 0.01 is 1/100, so you can think of it as a fraction, and 1/100 in base 10 is 1/10 squared. Bring it up to the numerator, it's 10 to the negative second power. And so evaluating this is, so this would be -2, because I know 10 to the x equals 10 to the negative second. 10 to the negative second, working backwards, is 1/10 to the second, which is 1/100, which is 0.01. All right, so next one, log of 1. What's the base? The base isn't written, so the base is 10. So 10 to what power equals 1? Well, anything to the 0 power is 1, so this is 0. 10 to the 0 equals 1. Log base 36 of 6 means 36, the base here, to what power, because we're trying to find the exponent, equals 6. So if you think about it, 36 to the 0 is 1, that's too small. 36 to the first is 36, that's too big. So if you're looking at like 36 compared to 6, if you took the square root of 36, you would get 6. How do you write an exponent that makes it a square root? It's 1/2 power. So 36 to the 1/2 means the square root of 36, which would be 6. So this is 1/2. All right, why don't you try these two and then come back. So this first one, log of base 49, 49 to the what power equals 7. Again, that is a square root, which is the same thing as raising something to the 1/2 power. And then this one here, erase some of this stuff here, 2 to the x equals 1/8. Make 8 into base 2. It's 1/2 cubed. And then bring it up. It's 2 to the negative third power. So 2 to the what equals 2 to the negative third? Well, it would have to be negative 3. 2 to the negative third power is 1/8. And in our next video, we're going to get into how to graph a logarithm. So that is it for right now. Hopefully you're now able to do the 4.3 practice.